Okay, so we'll talk about using this diffraction grading. This one has 15,000 lines in there. So in that little 1-inch region, it has got 15,000 lines. So it basically serves as a grading, and if I look through this, you should be able to see a spectrum. And it turns out that the diffraction results in different colors being diffracted differently. So let's turn on this incandescent bulb. This is just an ordinary bulb. And if you turn it on, and if you look at it through this diffraction grading, you can see the colors being split uniformly. There is a horizontal line. Ignore the horizontal line. That's just the holder of the light bulb there. So this is an incandescent bulb, which means that it generates light at different energies. The photons are coming out at different energies, a continuous spectrum of energies, and you can see the full spectrum ranging from red to blue, which is what we call the visible spectrum in there. Now let me turn that light off and turn the second bulb here. And this particular bulb is basically a vacuum tube filled with hydrogen in there, and there are two electrodes and a high voltage across it. Let's see where the switch is. It's right here. So I'll turn it on, and it's sort of glowing in one color here. It's actually not a single color, but if you go and put the glasses on, let me move off a little bit to here, and what you see is several copies of it at different wavelengths. You see a faint purple one, see a blue line, and a red line. So the purple there is made of those different colors, and they are being separated out by the diffraction grading. But what's most important here that you see is that there is nothing in between. So only fixed energies of light are being emitted by this hydrogen gas atoms, which are being heated by the high voltage there. So there are only discrete energy levels that you see coming out of the hydrogen lamp. That's interesting. Compared to an incandescent light, this one has got discrete photon energies which are coming out. That's the quantum nature that we're going to explore. So let's turn this bulb off and try another one. So this one is a power supply which is powering the lower one here. It's a neon filled tube. So this tube, similar to that tube, is now filled with neon. It's glowing in red. Now let's look at this one through the diffraction grading, and you see again a discrete set of colors. Here the pattern is a little bit thicker lines because the bulb is thicker. Right? The other one had a very nice thin tube. So you can see the discrete yellow, orange, and red lines that you see from the neon gas which is filled in there. So the hydrogen gas and the neon gas are emitting light in very, very different ways at specific energies, if you like. So there are certain energy levels which are allowed and others which are not. Now we'll look at a little bit more complicated spectrum coming from this bulb. This is the Mercury bulb. It's glowing in blue, and you can see that there are three main energy levels that light is emitted at. There is a almost UV, which is bright blue. It's dim, but it's a bluish light, which is the highest energy photons. There are photons coming out at lower energy, which is in green, and even lower energy in yellow. But they are discrete. Not every wavelength is emitted like in the incandescent bulb case, but specific energies of light are emitted. There are lots of other lower intensity lines that are also emitted by these gases, which we cannot see very clearly. But what is very important to realize is that these pure gases, when they're heated up, when they're energized, produce electromagnetic spectrum which is very, very different from what you get from a just regular light bulb like this incandescent light, which here we just heated the tungsten wire and it emits light at all frequencies, whereas gases are emitting at discrete levels. And study of these spectra allowed the discovery of quantum mechanics at the end of 19th century and beginning of 20th century, which has completely changed our understanding of how matter, light, and the phenomena associated with this work.